Today I'll be doing problem number 67 on page 51 of the Physics BAP Chapter 2 homework. The problem reads, a stuntman sitting on a tree limb wishes to drop vertically onto a horse galloping under the tree. The stuntman is pictured here, and the horse is pictured over here. The constant speed of the horse is 10 meters per second, shown by this arrow, and this value of 10 meters per second. And the man is initially 3 meters above the level of the saddle, which is this distance x over here, 3 meters. Part A. What must be the horizontal distance between the saddle and the limb where the man makes his move? That is our first problem, which will be done in this space over here. Second problem. How long is he in the air? Well, first of all, we can calculate how much time it takes him to get from the tree to the saddle. We know he has to drop a total distance of 3 meters. We know his initial velocity is 0 because he is dropping from a tree. He is grabbing on and then letting go. And his acceleration will be negative 9.81 meters per second squared. This is the gravitational constant on Earth. So here we can plug our values into the equation. We can plug in 3 for x equals initial velocity, which is 0, time, which we don't have, which we're solving for, plus 1/2 acceleration by gravity, 9.81 meters per second squared, times time, which again we don't have because we're solving for it. Now, we're going to multiply 9.81 by 1/2, and we're going to get 3 equals 0 time plus 1/2 time, we're going to have, so this is 0 times time is nothing, so we can take that out of the equation. So 1/2 times 9.81 meters per second squared is 4.905 meters per second squared, and that is multiplied by time squared. These are in meters and meters. So now, if we divide both sides by 4.905 meters per second squared, we will get approximately 0.611, and the units for this, we have meters divided by meters times seconds squared, so we're going to end up with seconds squared equals time squared. Now, if we square root both sides, we will get a value of t equals 0.782 seconds. So for time, we can put 0.782 seconds. That is the answer to part B. Now for part A, we will be able to use time equals 0.782 seconds as one of our values. So if we clear this off for now, we can replace it with the values needed to find the distance the camel needs to be, or the horse needs to be away from the stuntman, so the stuntman can drop onto it and not land on the ground. So we have a distance x, which we are solving for. We have an initial velocity for the horse. We have 10 meters per second. This horse is going at a constant speed, so acceleration is 0 meters per second squared. And final velocity, because acceleration is 0 meters per second squared, is also 10 meters per second. We have a time we solved for earlier, 0.782 seconds. And we're solving for distance this time. So if we plug in our values, we're solving for x, so we're going to leave, change in x, bring down the 1/2, add initial velocity, 10 meters per second, to final velocity, 10 meters per second, multiply that by time, which is 0.782 seconds. 10 meters per second plus 10 meters per second times 1/2 equals 10 meters per second. Multiply that by 0.782 seconds. We're going to bring down, change in x one more time to get the final answer for A. Because we're multiplying by 10, move the decimal place over 1. We have seconds up here, seconds down here, so we can cancel the 2. So we have 7.82 meters. So for answer 67A, the horse needs to start at a distance of 7.82 meters behind, so when the stuntman drops from the tree, he will land right on the horse in 0.782 seconds, which is the answer for problem B. That's it for this problem. I'm Ian Liu, and I'll see you next time.